Problems on Newton's laws of motion. What net force is needed to give a mass of 250 kg an acceleration of 30 centimeter per second square? And the same we need to find for an acceleration of 30 meter per second square. So it means there is a mass which weighs 250 kg and a force is applied. So if the mass is moving at 30 centimeter per second square, what is the force? And if it is moving at 30 meter per second square, what is the force? So we need to find F1 and F2. So the given data and this problem is mass and acceleration. We know that force and mass and acceleration are related by the equation given by second law of motion. Force F is equal to mass m into acceleration. Means F is equal to m into a. Take the first part of the question wherein m is given as 250 kg and a is given as 30 centimeter per second square. We need to convert this into meter because in this equation acceleration is in meter per second square. So 30 by 100 meter per second square, since 100 centimeter is 1 meter. Therefore, force is equal to 250 into 30 by 100, so which is 75 newtons. Now let us take the second part of the question wherein m is the same 250 kg since it is applied on the same mass and acceleration a is 30 meter per second square. That means we are giving higher acceleration. And we know that when you give a higher acceleration, when you want to push a particular mass with a higher acceleration, then we also need higher force. So let's see what the force is going to be. So therefore, F is equal to 250 into 30. Since meter per second, we'll take it directly. So this is 7,500 Newton. So we understand if you want to give higher acceleration to move the body, and we need to apply higher force. A constant force F pushes an originally motionless 300 grams mass a distance of 2 meters in 3 seconds across a frictionless table. Find A. What is its acceleration? And B. What is the force? So, we understand that there is a mass of 300 grams and a force F, a constant force. The surface is a smooth surface. That means there is no friction. He says frictionless surface. So whenever there is a friction, then friction force also acts on it and it may reduce the acceleration by which the force applied also changes. Whereas this is a frictionless table, so that's not an issue. So now we need to find its acceleration when this force is applied on 300 grams. It moves 2 meters in 3 seconds. So this is the distance it has moved in this time and this is the mass. Now what is the acceleration? So to find the acceleration, what we have from equation of motions, we know that we can use one of those equations. S is equal to ut plus half a t square. We selected this equation because we know that it is starting motionless. That means u is equal to 0. U we know, and T we know, which is 3 seconds, and S we know, which is 2 meters. Hence, we can find A. So, applying the figures, S is equal to 2 meter, U is equal to 0, T equal to 3 seconds. So, by putting these values into the equation, we get 2 equal to 0 into T, which is of course 0. So, it doesn't matter when we multiply with 0. A is an unknown factor, 3 into 3. So, 2 is 9 by 2A, or A is equal to 4 by 9, which is nothing but 0.44 meter per second square. So, the acceleration is 0.44 meter per second square. Now, we know the acceleration. We can find what is the force applied since we have the mass with us. So, let's find out the force. From Newton's second law of motion, we know force F is equal to mass m into acceleration. Force applied on the mass of 300 grams by which it has moved with so much acceleration. So, F is equal to m into A, where m is 300 grams, which need to be converted into kg. So, which becomes 300 by 1000, since 1 kg is equal to 1000 grams into, and acceleration is, let us take the fraction because we can cancel it. So, 4 by 9 meter per second square. So, now 3 3s, 300, and 0 0, and 2 2s, 2 5s. So, this becomes 2 divided by 15 meter per second square. In other words, 0.133 newtons. So, the force that is required to move the mass on this frictionless table at an acceleration of 0.44 meter per second square is 0.133 Newton.